Okay, this is chapter 1.2, solving multi-step equations. To solve multi-step equations, use inverse operations to isolate the variable. This sounds a little confusing, but multi-step operations or equations just means you have more than one step. Inverse means the opposite, and isolate the variable means to get the variable by itself. So this is what it looks like, and I know you've seen this. So we have example 1 talks about the height of a tree after a certain number of years, and they have an equation. It grows 1.5 times x a year plus 15, and they want to know how tall it'll be after 24 years. So how many years it will be before it's 24 feet tall. Let's make sure we make sense of that. So the x stands for the number of years the tree is growing. And it might be that it's planted at 15 feet. It's planted at 15 feet and it grows 1.5 feet every year. We want to know how long it takes till it's 24 feet tall. And that's not really what's important here. What's important is that we figure out how to make these equations kind of dance for us. So we're going to use, this is a two-step equation because we have 1.5 times x, and that's multiplication, but we're also adding 15. So we're going to undo, we're going to do the inverse operation, and we're going to work backwards toward that x. So I'm going to leave the 1.5x alone for now, and I'm just going to concentrate on getting rid of the 15. And I do the inverse operation by subtracting 15. And I have to do it to both sides so that it's balanced. Okay? And so that leaves me with 1.5x on this side because 15 minus 15 is 0. See, we're always trying to find 0. And that equals 24 minus 15. And I think that if I subtract those, I get 9. Because 15 plus 9 would be 24. And then I have to do my second step. As a multi-step, I'm still doing the inverse. 1.5 times x. We're going to do it divided by 1.5. I should change colors again just for fun. We're dividing by 1.5, and we have to do it to both sides. So this looks like a weird fraction with a decimal in the bottom. These cancel out. 1.5 over 1.5 is equal to 1. Well, that's why 1 is a super important number. So that leaves us with 1x equals 9 over 1.5. Now, I don't know exactly how you want to solve this, whether you get out a calculator, do you do long division. We can do 1.5 that goes into 9 and add a decimal. Move that one over, make it 15 into 90 so that it looks like this, and then do long division that way. It should go in evenly. We could also try to think about adding up to 9 using 1.5. 1.5 plus 1.5 is 3. And 3 goes into 9. 3 goes into 9 3 times. And 1.5 goes into 9 twice. So, or goes into 3 twice. So it's 2 of these for every 3, and it takes 3 9s. So it's kind of like 2 times 3 equals 6. So x is equal to 6. And that's how many years it would take for it to be 24 feet tall. So 6 years. And let me just throw it in real quick just to make sure that you believe me. I moved the decimal here with 1.5 into 9, which is the same as 15 into 90. And if I put 6 here, just to try it, 6 times 5 is 30, and 6 times 1 is 6 plus 3 is 9, and it worked out. Okay, very good. That's the first one. We've got just a couple more examples, and then I'll let you practice on your own. We have 8x minus 6x minus 25 equals negative 35. Okay, multi-step equation. Now, I might want to combine like terms. That's one of those things that we're going to talk about. Combine like terms. These are terms that are the same. Okay, and our two x's are like terms. 8x minus 6x actually is 2x. So we're going to combine those two. And now we still have a multi-step equation. Now I want to work my way toward that 2x. I'm going to add 25 to both sides. If I'm going too fast, you can always stop the video and watch it again. Negative 25 and positive 25 cancel out to be 0. So it just leaves 2x. And then I have to think about this negative 25 plus negative 35 plus 25. Take the absolute value of each so that it's 35 minus 25 equals 10. And then I'm going to remember that since this is more negative than this is positive, that it stays negative. That's the way you do those. And then real quickly, I'm going to divide both sides by 2. So x is equal to negative 5 because negative 10 divided by 2 is negative 5. Okay, that was quick. Hopefully you don't mind that I went that fast. Do the same thing for every assignment in here. We have one more, the distributive property. Oop, let's spell that right. Okay, hopefully that's spelled right. Property, distributive property. Okay, now this is one of my favorites, so hopefully you like it too. This shows it like this: 2 times parenthesis 1 minus 5x plus 4 equals negative 8. This is example 3 on page 13. Okay, so the distributive property is where you distribute everything here. This is 2 times everything in the parentheses. And so we are actually going to multiply the 2 times the 1, and then we're going to multiply the 2 times the 5x. So 2 times 1 is 2, 2 times 5x is 10x, and we're going to leave the negative sign in the middle. So it's kind of like 2 times negative 5x is negative 10x. And we're going to continue writing the problem out, and then do the next step. I have a couple of terms I could combine. That's combining like terms. A positive 2 and a positive 4 can be recombined as 6. Negative 10x has to be left alone. Okay, I'm one step closer. Every time I do something, I should be a little closer. This is going to cause me some troubles, but I have a positive 6 here, and I have to remember that that's positive, and I have to subtract it from both sides. I probably should have put this little line down here. Okay, so I'm subtracting 6 from both sides, and that gives me something a little silly to look at. That becomes 1. I have negative 10x, negative 8 and negative 6. Well, if I add 8 plus 6, I get 14. And because they're both negative, that's negative. Now I've got a negative 10x equals negative 14, and I want to get that x by itself. I think I forgot to change colors, but I think you'll forgive me. I'm going to divide both sides by negative 10. If I do that, then this cancels out and makes 1. So I'm going to kind of scooch over here. Hopefully that's okay. X is left, and I have negative 14 over negative 10. Those negatives really cancel, and it's 14 tenths. And I could simplify again and call that 7 fifths. And that's probably how you're supposed to leave it, but you also could write it as 1 and 2 fifths. Either is okay. Okay, because 7 fifths is the same as 1 and 2 fifths. It looks like they used a calculator, and they got 7 or 14 over 10, and they didn't even really use a calculator. They just used their brain calculator. When you divide 14 by 10, you just move the decimal over one place, and it's 1.4. I think you'll find that 1.4 is the same as 1 and 2 fifths or 1 and 7 tenths or 7 fifths. So sometimes it's hard to know exactly how the book wants you to put an answer. This time it looks like it's a calculator exercise, but you still must show all your work. This is how you do every assignment on this, every problem in this assignment similar. Look for those distributive properties and make sure you do the inverse operation and undo the problem until you're left with the variable, the x or the y or whatever it is.